arrive, okay, the next one will be there in 2 milliseconds.
Yeah, but in UDP there's no insurance at all.
No, that's true, that's true. So it's a pity. That's just
Yeah.
an idea.
Yeah, that's true.
Okay.
So the basic assumption to make this experiment is that the packet has to arrive at some point.
Maybe I missed it, but for this last sheet, I was understanding that your CACE was more kind of a model how to communicate between robots. But now it's in a chart together with TCP. Well, TCP is a network protocol. So is CACA then a network protocol, or maybe I'm misunderstanding it?
It's something in between. So it's not really a middleware because it only provides it's only a distributed tuple space, and not. But it's also some kind of protocol because it allows you to resolve conflicts.
So what is it built on? Which protocol? Is it built on UDP?
Yeah.
Okay.
Okay.
And is this for full agreement? For the full agreement case? Or for any other
No, for
presented before?
no, this is only for the so when you have two instances of case, and you have sent a package from agent to another agent, and how much time you will need until the package does arrive at the second one.
Yeah.
So it's basically only evaluation of the half of all this thing.
Okay, but if you assume that you are using CACE, do you have any measurements of the time overhead of getting a full agreement between four rows, for instance?
Not yet.
I have one question. So you're basically deciding when you have two proposals, you decide based on a timestamp, right?
No, you can choose based on what you can decide.
Okay, so my question is on the timestamps. If you synchronize by timestamps, then you are okay with it for your program, but you gain another problem of synchronizing the timestamp. So how do you do it?
No, it's only one way to do it. So this is the basic idea that you can choose all these three components. You can choose how you distribute your proposal, then when you accept the proposal, and how you determine the final value. So let's say, of course you are right. If you would decide on a timestamp, then if the times are synchronized, you will have a problem. Therefore, we also use a Lampert time, which is it's a logical time. It's not a time like in seconds, since it's a Unix timestamp. It's just something that counts each time you send a message. And you can only also decide based on the information that's within the packet. You could, for example, say, okay, this is a robot that's closest to the ball, so I will take his decision where I should pass to, for example.
Okay, so that's optional.
Yeah.
Also on the last plot that we were discussing, I'm missing the bit rate, because of course if you send with a higher packet loss, if you send more times,
okay,
of course you have lower latency.
Yeah, that's true. This is we only send it after a packet did arrive at the other endpoint. So we made this experiment in a way that bitrate is not an issue. But of course you are right. If we would have sent it faster, then we would have more collisions. But then we would not need a third dimension for this plot. But it's yeah. Mm-hmm.
From a pure theoretical point of view, is there such a thing as mutual agreement? Because I'm certainly not an expert on this, but I can recall from a lecture from long ago that there's a problem that if you send a packet and then the other one acknowledges it, then it doesn't know whether the first one received the acknowledgement.
Yeah.
And there's an infinite problem actually. I mean, the more packages you send, the lower the probability that you're not in mutual agreement.
But if you need this one, then you need. This is the reason why we could need this three-way handshake. So if on the lowest level you can decide on whether you are interested in that message. If that message also arrived, then this one will be able to ensure that this agent has received the acknowledgement.
Yeah.
So, but if you do the full way, three-way handshake, then you will have a lot of messages, obviously.
But there's even a four-way handshake, right? I mean, theoretically, it doesn't stop there. At some point, you don't know whether the other one knows, whether you know, etc. It sounds strange, but
we are not usually not interested in. This one does not need to know whether this one did receive the last acknowledgement,
okay.
because this doesn't provide you any interesting information.
Yeah.
You can actually stop if you assume that you can lose something, but if you get the third one, then you can assume that the second robot has received.
That's true.
If that's,
Yeah. I once heard this metaphor about two armies that have to invade one. They're both on a hill and they have to together attack an enemy, and they have to send a messenger through the valley to the other side. But then they have to make sure that they attack at the same time. And apparently, theoretically, there's no way of knowing each of them that they can attack at the same time. But they can lower the probability to a certain amount. But that reminds me of this. But I guess that at some point it's just okay to know.
But we have less than 5 minutes left, and you also had the second part of the question speech.
that's why I asked.
We have to hurry a bit.
Average.
Yeah.
I'd expect a large overhang in terms of time.
Yeah, that's true.
There you go.
Just 3 slides, just to update the community, because we have this nice practical session with a survey. You all participated, and the results are that we ported our team software from C# to C++. So, because that was one point on almost every sheet of survey we got from you, that you don't want to use it because it's coded in C#. And we added some new features. One important point is that it's independent of any other library now. So we made the step you suggested already, like coding your software like a library and have some interfaces, and then over these interfaces you can use ROS, but you don't have to. So that is the way we coded Alisa now. So you can use ROS, but you don't have to. So we have a communication interface and a clock interface. You have to implement by your own if you want to use Alisa. So just what you need to know is that we compile with CMake, and we use the C++ 11 standard to have something like shared pointers and stuff. Yeah. The bad thing about that is that we have to port all other software we had before too. So we are in a similar position based on the software like ASML. We have to recode almost everything at the moment. Yeah, we talked about at the lunch. You were right. We know what we want to port, and you are inventing stuff new, so that's a little bit easier for us. But yeah, if you or anyone who is also using C++ and has some generic MSL modules like a RefereeBox client, we would kindly ask to use it, so save some time if you would be that kind.
Why is it that you have to port the other things?
Yeah, very complicated issue about C#, ROS in the past, and our build chain. So it's easier to port and recode stuff in C++ for us at the moment than to further support our build chain, which was formerly based on ROS to closely interconnect them.
Because the other things are also not good libraries.
Yeah, something like that. So, but luckily, like some processes like the motion and the vision were already in C++, so we are happy there. But
it has nothing to do with C++ in itself. It could have been anything.
Yeah. Yeah. So one other thing, just to make some commercials, we have to offer a postdoc position in April next year. So initial contract 3 years, extension in the research areas. So it's just 3.5 hours from Eindhoven. Yeah, you would
And what one person will be the leader of the RoboCup team.
Yeah.
Interviews are Wednesday after 1 o'clock.
Yeah. So if you want your own RoboCup team, Carpe Noctem, you can apply, maybe. And one of our current hardware problems is that we have problems with our gear shaft, which is broken quite often. Let's say we start to develop our hardware like it is now 2010, and after 2 or 3 years, a lot of gear shafts broke suddenly. Like over the years, it's not managed to hold that long, and now we have to reconstruct. And our first redesign ideas are based on the Tech United turtle, like form fit version, but we would like to have a look on your solutions in wheel suspension, and kindly ask to show your solutions on hardware during the workshop. That's basically it. I just want to announce to the community shortly. Maybe you have some questions, I don't know. Otherwise, next one.
Maybe one very short question, because we
Yeah, what's the state of the documentation of the Amica library?
Yeah, as it's not finished completely yet, so we just copied the source code comments from the C# to the same methods in C++, and starting to write some internal wiki entries how to set up the framework at all, and some tutorials and examples which we could use to make a more public documentation. But at the moment we have no documentation. I can give you, and you are fine, so you would need our support to make it work, but I don't know, maybe in 3-4 months there could be some good documentation. For example, the plan designer you used in the last workshop, we are planning to make some video tutorials how to set it up and use it, and some basic modules. It's like we think of it like like in ROS, where they have these tiny turtle simulator sending around with some easy messages, something like that. These basic tutorial like that will be there in some month. But yeah, nothing we could share really easy at the moment. But we want to provide something like that in future.
So if teams are interested to actually use it, is then your advice to wait another 3-4 months, or could we start right away? Given the state of the library and its documentation.
I would say wait 2 or 3 months, and then you can get a mostly working version where you will get some tutorials by us in person. So we would provide the information, but we don't have the documents set up yet. But if you want to use it in 3 or 3 months, maybe could be some state of which is okay to deliver. At the moment we have some modules not ported at all, which is about these constraint satisfaction modules, which are optional, and some conflict management module, basically stuff that goes wrong if you port C# code directly to C++. Something like with memory management, because you don't have a garbage collector in C++ and that stuff.
And would it be an option to send a student to your place? Student of ours to investigate or to learn actually how we could use it? Would that be possible? Would you have the resources to guide him or her?
Absolutely.
Yeah.
we can even send a postdoc.
But I'm not sure that he will return.
April next year. From April next year only. Postdoc.
Yeah, the student we can send tomorrow.
Then postdoc can follow.
code is almost worth it. So if somebody comes to us, it's very easy to support him that he can develop whatever.
Question, can't you or shouldn't you clearly separate the state machine from the decision making for the process? That should not be one single piece of software, no? Because the insatisfaction, it's a generic library.
Yeah.
It shouldn't depend, there shouldn't be dependencies there, yes? The state machine thing.
Yeah, you
There's
can.
nothing in the state machine that depends on just insatisfaction.
Yeah, it's like you say, we could start developing and driving around, but it's the uncomfortable way for us. We like our constraint satisfaction because we say you stand wherever a point is which is not blocked by something, and you